Welcome to Unit 2, Linear Equations and Inequalities. Our learning objectives for this unit: graph points and equations in a rectangular coordinate system, determine solutions of linear equations in two variables, graph a line using the slope and Y-intercept, find the equation of a line, solve and graph real-world linear problems and identify the properties of a function, and graph the inequalities in two variables. Now let me bring up the ebook. Remember, you have to enable Flash by clicking here and then choosing the allow, assuming you have Chrome. And I'll close that. And I'll reload. Okay. So, I've got that up. Graph points and equations in a rectangular coordinate system. Let's talk about that. As soon as I get my tablet, there it is. We got a rectangular coordinate system. And this line going here is the x-axis. This line going up and down is our y-axis. Now, if we look at the numbering on them, as the x-axis goes to the right, numbers become larger, starting with 0 right here in the middle. So 1, 2, 3, so on. This way, they become smaller. -1, -2, -3. For our y-axis, as they go up, they become larger. So 1, 2, 3, so on. As they go down, -1, -2, and -3. We have something called quadrants. And it starts with this first quadrant right here. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. So it goes maybe opposite what you think in terms of clockwise. So it goes counterclockwise. We also have this place where they intersect. This has a name. It's called the origin. And we haven't talked about points yet, but point notation, that would be 0, 0. And like I say, we'll talk more about that. Let me erase that. We have something called a point. This is where you have a beginning parentheses, then you have a number, then comma, and then another number, and then closing parentheses. Now this first number here represents the x part. And this represents the y part. Now here's x equals 1. And here's y is equal to 5. Now for x equals 1, there's an invisible line there going up and down, crosses through 1. For y is equal to 5, there's an invisible line going across like this, horizontal. Where they intersect is going to be where our point is. So this is the point 1, 5. It's also called an ordered pair. If I had another example, -2, 3. Here's -2 on our x-axis. Here's 3 on our y-axis. Again, where they intersect is where we put our point. It's kind of like that game Battleship, if you ever played that, where you do the intersection. Say A5. You do the intersection of A and 5. Now that's points. Then we get into equations. For example, if I have y is equal to 3x minus 1. Although there's different ways of graphing this that we'll talk about, we're going to take a look at using points, so plotting points. We build something called a t-chart. And you may have questions that deal with this. They'll ask you to build a t-chart. Now, we can pick anything for the x values. So let's say I pick 0, 1, and 2. You could choose 0, 5, and 1 million. You could choose negative 17, 3, and 50. You can choose any values. You want to keep them fairly small, though, because otherwise your y value becomes too large or too small. Then, I'm going to take each one of those. I'll start with the x equals 0. I'm going to plug that in to my original equation here. So y is equal to 3x minus 1. So I got 3 times 0 minus 1. 3 times 0 drops away, and 0 minus 1 gives us negative 1. I'm going to then plug in 1. So I'm going to go back to y equals 3x minus 1 again. I'll plug in 1. 3 times 1 is 3, minus 1 is 2. And then we'll plug in our third one, x equals 2. So I'll plug that in for x. So I got y is equal to 3 times 2 minus 1. 3 times 2 is 6, minus 1 is 5. Now that we have those 3 points, we're ready to plot them. 0, negative 1, be right there. 1, 2, be right there. 2, 5 would be right there. Then you draw a straight line through them, and that'd be your graph. Now that's by plotting points. I'm going to show you another utility. It's called Desmos to graph these. And this is www.desmos.com. And once you get here, you can click this Start Graphing. And we just type in exactly as you see it. Y is equal to 3x minus 1. Once you get done typing it in, you see that it will go ahead and graph it here. And that would be our answer. This does not do points though, so if you got a problem that's asking you to build a t-chart, you have to understand this technique here. Let's take a look at another example. And then I'll talk about all the different ways that you can use Desmos. Y is equal to x squared minus 1. Part of the problem of using a t-chart is you kind of have to have an idea what it looks like before you begin. How many points do you need? I don't know. Depends upon which one you pick in this case. I generally know what this looks like. I generally know where it's at, so I could pick the correct ones to get the picture. But if you did 0, 1, and 2 here, then you'd think, well, that can't be the entire picture. So you might do 3. Still might not be your picture, so then you maybe do a negative 1. And then negative 2. And then you say, okay, I understand what it looks like now. Okay, I'm going to do a -2, -1, 0, 1, and 2. We're going to type each one of these. We'll put each one of these in for the x. Okay, so -2. I'm going to have y is equal to -2 squared minus 1. -2 squared is 4. 4 minus 1 is 3. Then we're going to plug in -1. We got y equals -1 squared minus 1. -1 squared is 1. 1 minus 1 is 0. And then we'll plug in x equals 0. We're going to have y is equal to 0 squared minus 1. 0 squared 0 minus 1 is a -1. I'll plug in 1 into the original equation. I got y is equal to 1 squared minus 1. 1 squared is 1 minus 1 is 0. And if I plug in x equals 2, we got y is equal to 2 squared minus 1. 2 squared is 4. 4 minus 1 is 3. Even if you like to do these by hand, doing the t-chart, even if the homework problem doesn't ask for you to use the t-chart, I would recommend using the Desmos to get a feel for what the graph looks like before you begin. That'll help you figure out how many points you need. -2, 3. Be right there. -1, 0. Would be right there. 0, -1. Would be right there. 1, 0 would be right here. 2, 3 would be right here. I still maybe don't know what it looks like. So maybe I'd do 2 more points. I know generally what an x squared looks like, though. It's a parabola. It's a U-shaped looking graph. So, more or less, that's what our graph would look like. Okay, now if I'm doing it in Desmos, you can click the X here to clean that out, or you can just do your backspace. Y equals X, and then here I'll do the caret. Caret is above your 6, so if you hold down your shift key and do the number 6, it'll put it up in the exponent. And then if I do squared, and then I do my right arrow key to get out of the exponent, -1. And you see we got our graph. Okay, now let's talk about generally what these graphs look like, and then I'll show how to put them into Desmos. Now x to the third generally looks like this right here. Well, again, this is an exponent, so if I do my backspace, do my y equals x, and then my caret, shift 6, and then 3, and then right arrow, get it out of the exponent, you see our graph. You see that's much better than what I came up with. I would have had to plot more points to get precision. Now, if you have other items here with x to the third, you may see a graph will look differently depending upon what numbers are there. You may have something that looks like that. X to the fourth, x to the fifth, all of those would be the same. If you have a problem, x to the third plus x squared minus x plus 7. You just have to remember when you type this in, you do a right arrow key to get out of the exponent after each exponent's done. You know what I mean by that? Y equals x, caret 3, right arrow key to get out of the exponent, plus x caret 2, right arrow, minus x plus 7. Now, I'm going to use my mouse wheel, and you see, using my mouse wheel, I can see more of it up there. Mouse wheel is a button in the middle, in your mouse. You can also use these zooming, I'm supposing. if you wanted to capture this and paste it into somewhere, I'm not sure how you do that, to be honest. I usually press my print screen button, and that'll capture the entire screen. I take it in the Paint, and then I'll mark part of it and do an edit copy, and then paste it in wherever. I don't see any tools here really to copy it to the clipboard. No, don't see anything. Okay. Now, later on we'll be working with fractions. Y is equal to x plus 3 over x minus 1. If I do y equals, instead of sitting there struggling where in the world is a fraction at, and there's a way to do it with just the keys. You can come down here, and there's a one that's a fraction. Maybe I'm lying. I thought there was a fraction one. I don't see it. Either I've never had it or my memory's bad. Oh, maybe functions. There's a fraction, but that would be harder to use that. I guess I am wrong. I'm learning myself about this. Okay, well it's easy enough. If you just do a x divided by, you see how it creates a fraction? So the divide by does that. Which, if I'm down here, probably if I do an x and I do the divide by, this will create it. But I thought there was actually a fraction button. Now I don't have everything on top, so I can do my right arrow key to go back up there. And I want plus 3. I had to do my left arrow key because it threw it out of the top. X minus 1. Again, I'll do my left arrow key and then down arrow key, x minus 1. And I can use my mouse wheel. And that's what the graph would look like. Okay. Now we'll also be looking at absolute value. This is another one where you don't need to use that keypad down below. It doesn't hurt either. Y equals, if I just do the pipe symbol, it's over in the far right of your keyboard, above your enter button. So hold on my shift key, I get that. And then I can type in x plus 3. Well, left arrow, I guess, and then x plus 3. We get that. But again, if I come down here, see there's one that looks like an absolute value. If I click that, still puts my cursor to the right, so I have to do my left arrow key. And then you put an x plus 3. Again, even if you like doing it by hand, this really gives you a good feel for what an absolute value looks like. It's a V shape. Depending upon the negatives with it, it may open up, may open down. You see this plus 3 is shifted to the left of our origin, where if I put in a minus 5, it's shifted to the right. So again, gives you a good feel for what this stuff looks like. Square root of x. I don't even know how you do this one without the key down below. Probably type SQRT if I had to guess. Yeah. But there's a square root option down here, so I click that. And then, what was it? X, so just X. And that'd give us our graph. So that's the square root of x. Say the cube root of x plus 1. I really don't know where this is at, so maybe it's not here. Y equals cube root. Go to functions. Miscellaneous. Yes. Yeah, this is a radical symbol with an n. That n can be any number. So I click that. And I can put 3 here. And x, what did I say? Plus 1 and plus 1. And that gives us our graph. Now you can have the most bizarre looking equation here. And Desmos give that to you. If I had x caret to the power of the absolute value of x minus x squared. That's what the graph would look like. I could have all kinds of variations in here. Again, plotting points is nice if your equations are simple, but if you're dealing with anything more complex, then you need to really use some kind of utility, whether it's a TI3, TI4, or a Desmos utility or something. Okay, let's go on to determine solutions of linear equations in 2 variables. Now, when they say solutions of linear equations in 2 variables, what they're referring to, let me go to the next page, is they'll ask if a given ordered pair, a given point, is a solution of this equation. So they're giving us the x and y and wants to plug that in and check it. The idea on that is it leads into systems of equations later on. It's also used, if you're double checking your t-table. So, if I have 2x plus 3y equals 7. Oh, by the way, you don't have to solve for y in order to plug it into the Desmos utility. No matter what it looks like, you just type in exactly as you see it. So like this one, if I was wondering what this graph looked like, come over here, 2x plus 3y equals 7. That's what my graph would look like. Okay. Now if I was checking, (0, 2). 0, 2 kind of looks like it, doesn't it? Although you see if I put my mouse up there where the point is, it's not 2. But if I check it. Now this is our x and this is our y, so I'll plug those in. So I got 2 times 0 plus 3 times 2. And this is not equals at this point. This is a question mark equals. We're wondering if that's equal. 2 times 0 is 0, drops away. 3 times 2 is 6. End up with 6 is equal to 7, which is not true. So the question is this a solution to this? The answer would be no. If I had another one. I'm checking 1, 5. Well, again, if I plug this in for x, I plug this in for y, I'm going to have 5, where that's not equals at this point, it's a question mark. We're wondering if that's true. And then 3 times 1 plus 2. 3 times 1 is 3, plus 2 gives us 5. And I get 5 is equal to 5, so that checks. So the answer there would be yes. Now that's determining if a given solution is one of your answers. Let me grab a drink here. Now we've already talked about these. Graph equations of the form y equals mx plus b. Graph equations of the form ax plus by equals c. We haven't talked about that a little bit though. So let's discuss that. Even though that's not one of our current objectives. Because if you're doing it by hand, it does provide an alternative way. If you don't like T-chart. Let's say I got 2x plus 3y equals 6. I want to graph this. We can use this is the form ax plus by equals c. We can use the concept of intercepts to graph this. We're going to find the x-intercept. X-intercept is where it crosses the x-axis. What we do is you plug 0 in for y and solve. It's always into the other variable. So if I'm finding the x-intercept, I plug 0 in for y. So we got 2x plus 3 times 0 equals 6. 3 times 0 drops away and end up with 2x equals 6. Divide both sides by 2, and we get x equals 3. So this point would be 3, 0. Then we find our y-intercept. And again, you always plug 0 in for the other variable. So we're going to plug 0 in for x and solve. So I'm going to go back to my original equation up here. Put 0 in for x. So I got 2 times 0 plus 3y equals 6. 2 times 0 drops away. We got 3y equals 6. Divide both sides by 3. And we get y is equal to 2. So we'd have the point 0, 2. So I'm going to have 3, 0, which would be right here. And I have 0, 2, which would be right here. And then you draw a line through them. And that would be our graph. Now, if I'm using the Desmos, I don't have to find the intercepts. I just type this in exactly as you see it. And that'll give me my graph. Now, this next learning objective is graphing a line using a slope and y-intercept. So let's talk about slope. M, which represents our slope, is the change in y over the change in x. Now, a lot of books, a lot of instructors will use rise and run, and that's one of the worst ways to learn the concept. Think of it in terms of this: change in y over change in x, because you can put anything in here. You could put change in miles over change in gallons, miles per gallon. Change in change in miles over change in hours. Change in profit over change in time. Change in cost over change in time again. So you can put anything in for x and y. This is such a universally studied concept. It's half of calculus if you were to go on to that. You might say, well, when would I use slope? Well, if you say you're going to business, A lot of business majors get this wrong. Let's say in 2017, I said your profit was $10 million. Maybe you got a 500-person company. Profit means after all the bills are paid, everything's covered, salaries are paid, this is money free and clear. I'll ask in class, is that good? And almost universally, people be nodding their head, yeah, that's pretty good. You got $10 million profit. Especially if you got a small company like that, only 500 people. Well, how about if I said in the previous year the profit was $1 billion? Now it's horrible. You went from $1 billion profit down to $10 million profit. Liquidate the company, get rid of it immediately. It's going under to go have that dramatic of a decrease. How about if the previous year was $1? We went from $1 to $10 million profit. You're doing fantastic now. Expand, branch out in some areas. You just got whatever you're selling has just got some real appeal to the customers. Well, if you look at this now, we went from $9,999,999 to $10 million profit. So increase it by $1. Is it doing good now? Well, I don't know. That's this could be debated. You're not really losing, but it's kind of leveled off. If we're selling electronics, this is probably bad. Probably means unless there's other reasons why it would have leveled off like that, it could be that new technology is getting ready to come out. The new cell phone is going to come out and wipe out your old model. Could be you're selling toilet paper. You don't sell much more toilet paper from year to year, so maybe this is a stable amount. I had an individual in business. He ran an insurance agency in my class one time, and he said that in business, if you're not increasing, then you're going down. So your business is decreasing. I'm not sure if that's quite true, but that's the way he viewed it. He viewed it should always be increasing with your business. Like I say, I'm not sure if that's true for a toilet paper example. I know it's kind of a weird example, but this shows you that the amount you're making isn't the only factor. It's the rate of increase, which is what slope is about. I worked at a company that large private corporation, and it consisted of a bunch of smaller companies, and they would sell these small companies that are making money. And I worked in the programming side, the financials, and I could see that they're making money. And I asked one of the accountants one time, I said, well, why do they sell these companies? They're making money. And he pointed this out to me. He said, in this case, we could perhaps liquidate a company, take all that money, put it into a bank account, and make more of a rate of return than just $1 a year by doing nothing. And so he pointed out that this is one of the factors you have to consider when you're looking at whether something's doing well or not. Then again, this is not just about business, but you could apply this to many different areas, medical and so forth. Okay, now having said all that, all we're going to deal with is X's and Y's, but realize it's much more than that. It's not just rise and run, dealing with distance. It's just not X's and Y's, but a lot of different examples here. Now, I think that may be, when you're working some of the problems here, you see with the real-world linear equation problems, that's where you'll get an opportunity to experiment with different ones. Now, given 2 points, x1, y1, x2, y2, then our slope is going to be y2 minus y1 over x2 minus x1. So if I had -3, -2, 5, -6, and I wanted to find the slope between these 2 points, Well, first off, this is my first point, so I'll label this as x1, y1. This is my second point, so I'll label this as x2, y2. I'm going to go to my formula right here, and I'll replace my variables with sets of parentheses. That always helps when you got signs. You don't lose track of the signs as bad. Now our first variable is y2. So y2 we said was negative 6. So I'll plug that in here. Our second variable is y1, which is negative 2. Our next variable is x2, which is 5. And x1, which is negative 3. Now we simplify. Remember, a negative parentheses negative becomes a positive. So we got negative 6 plus 2. Over 5, and negative parentheses negative becomes a positive, so we've got 5 plus 3. Negative 6 plus 2 is negative 4. 4 plus 3 is 8, which reduces top and bottom both divisible by 4 to negative 1/2. And that'd be our answer. Some problems, especially at that real world application section, you'll have to determine what's your x and what's your y. That's sometimes a challenge. Let me erase this. Let's say after 2 years in business, then we find a profit is $1,000. After 5 years, we find our profit is $8,000. So they give that to us in a word problem. And you're trying to figure out which one's which. Which one's the important one. This is building upon the idea that x's are an important one. X drives the other one. In terms of function notation, which we'll see later on. Mostly you see it in college algebra, but the x values are our domain, the y values are our range. Domain is the important part. The domain drives the range, so the x values drive the y values. Which one drives which? Does the profit drive the number of years? Well, not really. You know, the fact that we have a $10,000 profit doesn't mean it's year 8 or year 50 or anything. Does the number of years that have passed drive the profit? That probably makes more sense as we'll build up our profit and so forth. Build up our business, sorry. So we're saying years drives profit, which means our years would be x and our profit would be y, because the one that's driving the other one is our x. So when I do my points here, number of years be 2, comma, profit, which is 1,000. That's our first point. Our second point would be 5, and then 8,000. Versus, we've put in 1,000, comma 2, or 8,000, comma 5. You have to think which one drives which. And that's not always the easiest thing. Sometimes I struggle in figuring out which one drives which. Okay, let's talk about the slope-intercept form. I see it says graph a line using slope and y-intercept. Slope-intercept form looks like this. Y is equal to mx plus b. Now m is a number and b is a number. So the m right here is going to be our slope. And the b will be our y-intercept. And this is, again, if you're graphing these, this is showing doing it by hand. If you're using Desmos, you don't need to use this principle. You just type it directly in. let's say I got y is equal to 2/3 x minus 1. And we're wanting to graph this. First off, our slope is 2/3. We always want to write that in fraction form, which this is already a fraction, so we're good. And then our y-intercept is a number at the end. So the y-intercept is going to be -1. Now remember, our slope is a change in y over change in x. This is a +2 over a +3. Now when you're talking about the slope, you'll have a number on top, a number on the bottom. If the number on top is positive, change in y, that means I'm going to go up. If the number is negative, that means I'm going to go down. The denominator down here, if it's positive, that means change in y over change in x, so x is left and right. If it's positive, that means we're going to go right. If it's negative, that means we're going to go left. What in the world does that mean? Well, here we have a +2, so that's saying up 2. Here we have a +3, which means right 3. So, to graph this, we go put our point at our y-intercept. So come down here and -1, and we put a point. Now from this point, we're going to go up 2 and right 3. So we'll go up 2, right 3, and that's where we put our second point. Now after you have your second point, you draw a line through them, straight line, and that'll be your graph. Okay, let me grab a drink here. And we'll look at another problem, another example. Y, oh, I didn't put an X here. There should be an X there. Y equals -3x plus 2. Well, it's in the slope-intercept form because it's solved for y. I'm going to show you one that isn't in that form and show how we solve for y. This would be our m, and this would be our y-intercept. So m is going to equal -3, and we always want it in fraction form. If it's not in a fraction form, you can put it over 1. And specifically, that's -3 over a +1. If it doesn't have a sign, it's by default positive. Now, negative, we said, is down on top. So this says down 3. Now, on the bottom is a positive, so that says right 1. So, what that means is we're going to go to our y-intercept, which is at +2, and we'll go put a point there. Now from there, we're going to go down 3 and right 1. So down 3, right 1. So 1, 2, 3, right 1, and we'll put our second point. Now after you have your 2 points, you draw a line through them, and that'll be your answer. Okay, so that's how to graph using the slope and the y-intercept. Question becomes, when you don't have it in the correct form, what do you do? For example, if I have 2x plus 3y equals 12. In order to use this technique, you have to have it solve for y. Well, we're going to use the principles we saw before of solving a linear equation to get to y by itself. So I'm going to take this 2x and I'll move it to the right side. Remember before when you said when you move anything across your equals, your sign changes. So this +2x becomes a -2x. Everything else remains the same in terms of signs. +3y, +12. Only what would move across equals changes. Then we're going to divide everything by 3. If we do, that'll get rid of that 3 and y will be by itself. So we got y is equal to negative 2/3 x plus 4. And now this is in slope-intercept form because it's y equals. Whatever numbers in front of our x's are m, and our y-intercept is at the end. So m is negative 2/3, which is negative 2 over a positive 3. Again, a negative on top means down, so that's saying going down 2. Positive number on the bottom means right, so that means we're going right 3. Okay, so we're going to go to our y-intercept, which is 4. We'll put a point. From there, we're going to go down 2, right 3. So down 2, right 3, and we'll put our second point there. Then after you get your second point, you draw a line through them, and that'll be your graph. Ignoring the fact I can't draw a straight line. Okay, let me clear that off. And then we got the find equation line. Equation line is still a slope-intercept form. Y equals mx plus b. Let's say that we're given that m is 2, and it passes through 1, 3. And we're trying to find an equation line that meets that criteria. Okay, find an equation line. Step 1 is to find the slope, m. Step 2, plug in the given point for x and y, and the and m from step 1 into y equals mx plus b, and solve for b. And then step 3 is to write your answer down. Plug in m from step 1 and b from step 2 into y equals mx plus b. Grab a drink here. Step 1. Find the slope. Well, this one's pretty easy. They give it to us. M is 2. Step 2. Plug in a given point for x and y. When they give us a point, they're giving us a specific instance of x and y that we can use. So they're telling us x is 1, y is 3. So plug 3 in for the y. It also says to plug m from step 1. Well, m from step 1 we said was 2, and then x is 1 plus b. And solve for b. So we got 2 times 1 is 2 plus b. Take the 2 over. Becomes a negative 2. 3 minus 2 is 1, so we got b is equal to 1. Then step 3 says write your answer. Plug in m from step 1 and b from step 2 into y equals mx plus b. Well, in step 1 we said m was 2. And from step 2 we said b was 1. So plug 2 in for the m and 1 in for the b, and that would be our answer. At that point we could graph it or do whatever. But that's how you find equation line. Now, not always will they give you the slope. Let's say it passes through (3, -2, and 5, 1). Now, steps are still the same. Step 1 says to find m. Well, remember m is the change in y, y2 minus y1 over x2 minus x1. This is my first point, so this would be my x1, this would be my y1. This is my second point, so that'll be x2, that'll be y2. y2 we said was 1, minus y1, which is -2, over x2, which is 5, minus x1, which is 3. Negative, parentheses negative becomes a positive, so we got 1 plus 2. 5 minus 3 is 2. So we end up 1 plus 2 is 3, so we got 3/2. Step 2. Plug in a given point for x and y. Well, we got 2 points. Which one do we pick? It doesn't matter. You pick whichever one looks easier to you. As weird as it seems, both of them will give you the same answer. So I'll plug in a second one because it doesn't have any negatives. Plug that in for x, plug that in for y. So we got 1 equals m, we just said was 3/2, times x, which is 5, plus b. And then solve for b. 3 times 5 is 15, so we got 15/2, plus b. If I'm not very good with fractions, I'll get rid of fractions now by multiplying everything by 2. 2 times 1, 2 times 15/2, 2 times b. I multiply by 2 because that's our denominator. So we got 2 equals 15 plus 2b. Take 15 over, we got 2 minus 15 equals 2b. Remember, you take anything across 3 equals, your sign changes. And that gives us -13 equals 2b. Divide both sides by 2. And we get b is equal to -13/2. Then step 3 was to write our answer down. Plug in the m we found in step 1, which is 3/2. Plug in the b we found in step 2, which is -13/2. And that'll be our answer. Now, in some cases, they may give you a condition saying that it's perpendicular to another line or it's parallel to another line. So let's talk about that. Find the equation of the line given a point and a line that is perpendicular or parallel. Step 1 is to find m. That hasn't changed, but it's got a sub-step. It says to write the given line in slope-intercept form. Solve for y. Then identify the slope. If it's in slope-intercept form, your slope is wherever's in front of your x. Then, at that point, we want to find our m. Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals. Okay, so let's take a look at a couple examples of that. passes through the point 1, 2, and is parallel to 2x plus y equals 3. Step 1, find m. Our first substep, write the given line in slope-intercept form. So we want to solve for y. So in this case, I'll take 2x to the right side. So we got y is equal to negative 2x plus 3. Remember, you take anything across or equal, your sign changes. Our second substep says to identify the slope. The reason why we put it in slope-intercept form is so we can easily see what our slope is. It's whatever number's in front of our x, which is negative 2. And then, third substep, parallel lines have the same slope. So we said it's parallel to this line. We said the slope of that line is negative 2. Parallel lines have the same slope, so m will be negative 2. They're the same. At that point, step 2 and step 3 are the same. We're given a point, so this is our x, this is our y. So plug 2 in for the y. M we just said was negative 2. And x is 1 plus b. Then we want to solve for b. Negative 2 times 1 is negative 2, and I'll take it to the left side, becomes a positive 2. And we get b is equal to 4. And then step 3, write our answer down. So we plug in what we said m was. M was negative 2. And plug in our b, which we said was 4. So our answer will be y is equal to negative 2x plus 4. Okay, let's take a look at a perpendicular to. I don't remember what I had, something like 2x plus y equals 3 or something like that. Step 1, find m. First substep, take the given line and put it in slope-intercept form. Solve for y. So I'll take 2x over again. It becomes a negative 2x. Second substep is to identify the slope. It's whatever number's in front of our x. So slope is negative 2. Perpendicular lines have slopes that are negative reciprocals. What in the world does that mean? Well, we start with a slope from 1b, which is negative 2. Then we're going to write it in fraction form. So write it in fraction form. How you can always create a fraction? By putting it over 1. Assuming it's not already a fraction. You may have 2/3 there, in which case you wouldn't do anything. This is already in fraction form. Then we're going to flip it. That's called taking a reciprocal. Reciprocal means top goes bottom, bottom goes to the top. So you flip it. And then you change the sign. So it goes from a negative to a positive. So m is going to equal to 1/2. So a negative reciprocal. Flip it, change the sign. Once you get used to the concept, it's pretty easy. You can probably do it in your head. But that's showing how to do it. Then step 2, plug in the given point for x and y. So plug that in for x, plug that in for y. So we got 2 equals m is 1/2 times x, which is 1, plus b. 1/2 times 1 is 1/2 plus b. I can multiply everything by 2. 2 times 2 is 4. 2 times 1/2 is 1 plus 2b. Take the 1 over. And you get 3b, or 3, sorry, equals 2b. Divide both sides by 2. And you get b is equal to 3/2. Just double checking myself. Yeah, 3/2. Then step 3. Plug in your m you found from 1c was 1/2. So we got 1/2 x, and plug in the b we found, which was 3/2. And our answer is y is equal to 1/2 x plus 3/2. Let me open my window just a little bit. Family's got the heat on, which is good since it's wintertime, but my little room, it gets extremely warm. Okay, so 5.5 is talking about functions. So we're going to introduce some concepts here. A function says for every x there is only one y. It's kind of a hard definition to work with. An easier definition of a function says if you have one of the following, then it is not a function. Y to an even power. If you got the absolute value of y. If you got a plus or minus symbol in front of an x of some sort. Or if you got x is equal to a number, such as x is equal to 5. Those are not functions. Now those are your most common ones you run across in problems. That's not all inclusive, so there's lots of other things that aren't functions, but those are what you see mainly in algebra. What'd that problem look like? They'd give you something like this, x squared plus y squared equals 4. They'd ask you whether this is a function or not. I come down here, if you have one of the following is not a function. If we have y to an even power, which this one has y to an even power, it's not a function, so the answer would be no. If I had y is equal to absolute value of x plus x to the third. We got y to an even power? No. Do we got the absolute value of y? No. We got the absolute value of x. That's okay. We just can't have absolute value of y. Plus or minus symbol. What that plus or minus symbol is, it looks something like this. Plus or minus x. That's the plus or minus symbol. Well, we don't have that. X equals a number. Now that's all you'll have. It'd say x equals 2, x equals 7. It wouldn't have anything else. Well, it doesn't have any of those. So in response, is this a function? The answer would be yes. Now functions have a lot of different items that go along with it. So let's see in particular what you're looking at. Okay, there we are. And my goal isn't to cover every item in here. just to give you a concept of, okay, the one domain and range. Function notation. And then graphs. Okay. So domain and range. It looks like they mainly present us in points. Now our domain is your x values. And your range is your y values. For example, if I had points 2, 3, -4, 1, and 5, 5, 6. So my domain would equal to 2, 2, -4, 5. And typically we write those from smallest to largest, so -4 to 5. Those are our x values. And our range would be our y values, which would be 3, 1, 6. Or, if I wrote those smallest, largest, 1, 3, 6. And those would be our range. Now they also talk about our function notation. Function notation has two purposes. One, to give it a name. What in the world does that mean? My mouse is clicking twice sometimes. Have to hit it to get it out of the double click mode. Okay, give it a name. Let's say I got y equals 3x minus 1. And I got y is equal to 5x plus 2. If I asked you to graph those, you'd say, okay, I'll graph those. If instead I asked you to graph y, which one would you pick? They're both y. So they both have the same name. So we'll give them a name. I'll call this one by this name. We don't give them a name like Bill and Bob or anything like that. And this one, I'll give it this name. Now how you pronounce that? That's read as f of x. Or we even get lazier in mathematics and we simply say f. This one's read as g of x. Or we simply say g. So now if I said, instead of saying graph y, I said graph g, or graph f of x, you would know which one I was talking about. So that's the first purpose of it, to give it a name. Now these are interchangeable, by the way. If you have a y, you can put function notation there. If you have function notation there, you can put a y. Some people like to put the y back for graphing purposes, and then some people like this notation for the next type. Second purpose of function notation is reduce writing. There's problems you'd see that look like this. It says evaluate y is equal to 3x minus 1 for y when x is equal to 5. Now what you do here is you got y is equal to 3, and then you plug 5 in for the x. Minus 1. This is evaluating. 3 times 5 is 15 minus 1, or y is equal to 14. Now instead of writing it with those words, you can simply say f of x is equal to 3x minus 1. Find f of 5. So it reduces writing. Now this is solved exactly the same way. We'll say f of 5 is equal to, and then we'll plug 5 in for the x. F of 5 is equal to 15 minus 1. F of 5 is equal to 14. That's a called evaluating functions. So evaluating functions. take a look at an example. If I had f of x is equal to x plus 3 over x minus 5. And it said find f of 8. Well, we'd go through, we'd replace all of our x's with whatever numbers inside this parentheses right here. So we're going to have 8 plus 3 over 8 minus 5. 8 plus 3 is 11. 8 minus 5 is 3. So our answer would be 11/3. And that's evaluating functions. Now this last topic is graphing inequalities in two variables. Example that. We got y is less than or equal to 2x minus 1. Instead of it being an equals here, we have inequality. It could be a less than, less than or equal to, greater than equal to. First off, let me show it in Desmos. If I come over here, I type y. I need a less than or equal to. You'll see down here, you got your symbols. I choose less than or equal to and 2x minus 1. This is a solid line and it's shaded to the right. And this would be your answer. Now notice instead of a less than or equal to, let's put a less than there. Difference is, when there's a line underneath, it's a solid line. When there's no line underneath your inequality symbol, it's a dotted line or dashed line. Okay, so if I was doing this by hand, what I do first is I pretend that it's an equals. So instead of inequality, I put an equals there. Keeping in mind that a less than or greater than is going to be a dotted or dashed line. And a less than or equal to or greater than or equal to will be a solid line. Now the y-intercept on this is -1. So come down here, -1. My slope is 2 over 1. So that's a positive 2 over positive 1. So it means go up 2 and right 1. Since this is a less than or equal to tells me use a solid line. Look like this. And that's step 1. If it had been a less than here, this would have been a dashed line, dotted line. Then we want to pick a test case. Now, a test case is just a point. Doesn't matter which side you pick it on. You just want to pick at the one that's really close to the line or on the line. If you can, you always pick the origin. That's always a really good one. And I can tell the origin is definitely on the left side here. So, I'm going to use 0, 0. And what I'm going to do is I want to plug this back into my original inequality and see if it's true or false. So if I plug that into y is less than or equal to 2x minus 1, put 0 in, this is x, this is y, so I put 0 in for the y. This is not really a less than or equal to, it's a question mark. And 2 times 0 minus 1, we end up with 0 is less than or equal to 2 times 0 is 0 minus 1 is a -1. Question becomes, is 0 less than or equal to -1? It isn't. It's false. Now if it's true, I shade the side where the point is. If it's false, I shade the other side. Since this was false, I shade the other side. Now if I'd come up with something that was true here, I would have shaded this side where the point fell. But that's how you graph linear inequalities in two variables. Now that covers all of our learning objectives. I'm going to go ahead and stop the recording, and I'll answer any questions you might have.